BIM has changed the way professionals in the AEC sectors communicate by using intelligent 3D models that are accurate and accessible, eliminating rework and helping to remove inefficient procedures, while 3D laser scanning solutions enable the capture of as-built conditions of a project to create an accurate as-built model to avoid costly rework by detecting errors early in the process. This is Mohamed Samir, Virtual Design and Construction Head at Kabbani Construction Group. The subject of presentation is Scan to BIM for infrastructure and heritage projects. By the end of this talk, you will be familiar with the Scan to BIM workflow within different types of projects, illustrating how the process works and what benefits it can bring. I will start off by explaining the basic concepts and workflows of Scan to BIM. After that, I will go on to benefits and challenges of Scan to BIM. Finally, I will show some examples of the use of Scan to BIM in actual projects. If you work in the construction sector, you have most likely heard the term Scan to BIM. You may have seen your construction partners in the field utilizing a 3D laser scanner. But what exactly is Scan to BIM and how does it work? What are the benefits and the challenges of adopting Scan to BIM technology? And how it can be utilized in infrastructure and heritage projects. All of these topics will be covered in this presentation. Scan to BIM is the process of creating accurate digital representation of a physical space or site by use of laser scanning technology, an effective BIM process. Reality capture solutions include terrestrial scanners that are currently the most famous one, and they are usually fixed on a tripod and moved from one scanning point to another. SLAM scanners allow you to continually scan while moving, whether you carry on your hand or fix on a robot. Scanners can provide a very high productivity rates. Mapping systems that you can fix on a moving vehicle in the drone's view and cover large areas. In today's presentation, we are going to focus on terrestrial scanners. So, how this works. A rotating emitter within the scanner case sends laser pulse. As the laser beam hits various objects, their position relative to scanner and to other elements is recorded as a piece of digital data. This is known as a point. When several of these points are collected, they begin to build a highly accurate three-dimensional digital model of the space being scanned. A large collection of these points is commonly referred as a point cloud. A sensor can capture panoramic 360 images that are used to define the colors for the points. Scan data is then imported into a 3D modeling software like Revit to create accurate as-built model that can be used for designing, assessing conditions, progress monitoring, evaluating different options, BIM-based workflows, reduce cost, making it easier to understand the final output. Here is a quick overview on our scan to BIM workflow. Failing to prepare is preparing to fail. That's why planning is always the key. We start by setting our scanning goals. We begin with the end in mind. What are the data is going to be used for? Our scanning method, for example, are we going to use targets? Do we need to use panoramic 360 images? Of course, panoramic 360 image will consume more time on site. Do we need to use special tools like elevated tripods? Based on project type, project phase, scanning goals, resolution and accuracy can be identified. A scanner is then selected based on the required resolution and accuracy, along with other aspects such as operating temperature. Based on scanner range, resolution, and accuracy, a map of scan locations is prepared. Software is selected based on the project type, goals, required level of detail, and project schedule. A BIM execution plan is prepared to illustrate how the project will be executed. Then we move to the site. We start by clearing the site from any object that blocks scanner site, setting lighting, especially if panoramic 360 images are required, setting scanning locations as planned earlier, setting targets if needed, Then we start the scanning process. We perform cloud-to-cloud registering where applicable, taking measurements to assure scanning quality, take photographs and tag them to the point cloud if needed, and set survey grid if needed. Data cleansing. Then the data is transferred from the scanner to a high-specs workstation to register scans together to form a single scaled scan with common coordinate system and export to RCS or RCP formats to use in Revit. At this point, we also publish the Panoramic 360 images on cloud to project stakeholders if part of deliverables. A native file is also submitted at this stage. 3D model. At this stage, we finalize the BIM execution plan and start execution with preparing the project templates, basic modeling, families of all objects as per the project requirements. During family preparation, we assign the proper geometry and information to make the model intelligent. The level of information can vary dramatically from one project to another. Deliverables can include point cloud, panoramic 360 images, whether on cloud or native file, 2D plans, elevations, sections, quantity reports, asset information models, etc. In an actual project, we may need to repeat this workflow before and after construction works, or during if needed. The output of scan to BIM of the as existing condition is used during the construction stage to get accurate as-built data in a short time and with very high quality. The final as-built data is transferred to the facility management team to be used in operation and maintenance. A scan to BIM workflow can be complicated for some projects, especially during the construction phase, while using the scan to BIM to monitor the progress or to check the quality of the installed services. You have to scan on several layers. During the planning and design stages, scan to BIM can help a project with improving the accuracy of site surveying. During construction stage, the application of scan to BIM help to identify the actual amount of work done and compare it with the plan. It can also provide seamless handover at the project closeout. An accurate as-built model of the building can facilitate operation and maintenance activities, as well as renovation or building future additions to the assets. Benefits of scan to BIM can be summarized as shown: high measurement accuracy up to millimeters that results in higher quality, very fast measurement up to 2 million points per second, consequently, project time is reduced, having fewer errors when planning renovations or extensions for buildings. Reliable floor plans in a modern standardized format are now easier to obtain, since laser scanning can provide higher quality while reducing project time. Increased profitability is assured. Benefits become massive once BIM benefits are considered. We won't get into benefits of BIM in this presentation as this topic needs a standalone one. I'm also sure that it is covered by many of my colleagues. Challenges to implementation of scan to BIM may include: laser scanners can be expensive, especially the most accurate ones. Lack of expertise in the market. Like any other technology, you first need to learn how to work with hardware and software. Resistance to change is always a challenge while adopting new technology. Most of BIM design tools, including Revit, are targeted at designing new buildings. It is difficult to use Revit for existing structures. To help you to get your head around, this section of the presentation will take you through scan to BIM workflow within infrastructure and heritage projects, illustrating how the process works, what are the main challenges in this type of projects, along with samples of deliverables. Let's start by infrastructure projects. Here we have some examples of KCG projects. The scope of work usually include concrete repair, moisture insulation, MEP works, scan to BIM before and after repair works. Scan to BIM of the actual as existing condition can feed the model with the most crucial information before designer or contractor start to work. Challenges in this kind of project may include high humidity and high temperatures, relatively large sites. You may also encounter accessibility issues. Concentrated MEP services can block the site of the scanner. High deteriorated areas are a real challenge during modeling and quantification. Poor lighting can be an issue, especially if panoramic 360 images are required. BIM software limitations. After the point cloud is exported to RCP or RCS format, BIM models are developed according to the point cloud and panoramic 360 images, along with information received from our site inspection team using destructive or non-destructive tests and GPR technology. Scan to BIM of the as existing condition can provide construction team with the most crucial information before they start their works. In this kind of projects, modeling automation can be really useful. However, modeling and quantification of deteriorated areas is a bit challenging. Here is a sample of 2D drawings extracted from Revit using Scan to BIM workflows. As we said earlier, automation is very useful in this kind of project and can save you a lot of time. Using machine learning algorithms, Dynamo and Revit, we created a full model of walls from point cloud data in one of our projects. In other projects, third-party add-ins were used to automate piping creation. Now we move to the heritage projects part. The scope of work usually includes heritage impact assessment, structural assessment, recommendations for restoration. Challenges in this kind of projects may include unavailability of as-built data in digital formats, highly damaged areas that can make site dangerous while scanning, health and safety issues such as damaged stairs, unstable floors, desert sites, etc. High level of detail requirements for BIM models to satisfy the archaeological team requirements. BIM software limitations. BIM models are developed according to point cloud and panoramic 360 images, along with information received from our site inspection team using non-destructive tests and GPR technology, in addition to data received from archaeological team. The final output of scan to BIM is shared with archaeological and inspection teams to include in their reports. Scan to BIM of the existing condition can provide inspection and archaeological teams with the most crucial information before they start their works. Building components are analyzed and identified to determine the modeling method and Revit categories that will be used to model the different building objects. Most BIM design tools, including Revit, are targeted at designing new buildings. It is difficult to use Revit for existing structures, especially in heritage projects. Here is a sample of 2D drawings extracted from Revit using Scan to BIM workflows. Integrating Scan to BIM with the structure condition assessment software of existing structures has added remarkable values to the outcome. Such integration is allowing the owner a higher level of control and management of the assets in a time and cost effective way. Thank you so much for your interest and attention. If there is one thing I would like you to remember from today's presentation, it is that BIM and laser scanning are quickly becoming the norm in construction projects. So if you are not using them yet, now is the time to start looking into bringing them to your projects in the near future. If you have any questions, I will be available after this presentation to answer all your questions. You can also send me any questions anytime you need on my LinkedIn or email or even WhatsApp. Thank you again and have a good day.